Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B topical MCQ for classification topic number 9.2, which is just to do with group 2 chemistry. So back then they used a Roman numeral, but in the modern papers, in the modern specification of syllabus, Cambridge International has adopted the numerical value to represent a group number, as you have seen in the modern periodic table, okay? So what is in this kind of question, I guess, I should probably start off by telling you that 1, 2, and 3 represent A being correct. So 1, 2, and 3 are correct is option A. 1 and 2 are correct is B. 2 and 3 are correct is C. Only 1 is correct is option D. Okay, so these are quite common for the Cambridge International Paper 1 MCQ. Although this kind of format has adopted in a couple of other examination bodies that I've seen, such as the IB as well as the Scottish equivalents of A-level, and a couple other exam bodies which I can't be bothered to name right now. Okay, going into this first question, this is saying that what would be expected of strontium and its compound. If I check option 2 first, we know that the thermal stability of the group 2 carbonate, so it's M2 plus and CO3 2 minus. Going down the group, the trend is something you'll be expected to state in S, something you'll be expected to explain at the A-level stage, yeah? So it becomes more stable down group 2, so that is more difficult to decompose. The thing is, it's quite hard for me to tell you that when I say it's more difficult to decompose, does it get decomposed or not? That's the thing that I can't tell you directly for now. If I go straight to number 1, so I need to check the other statement to make sure, right? When heated in oxygen, strontium does not burn. Okay, so when you think about group 2 metal combusting in oxygen, they'll give you the group 2 oxide, which is strontium 2 plus being a group 2 cation and an O2 minus being an oxide. Balancing equation, whatever equation you write, you got to balance with the correct formula and the correct mole ratio, yeah? So that's solid there. We think about oxidation state, there's strontium 0 going to strontium plus 2. So this is a redox reaction, by the way. The oxygen has been reduced to oxygen minus 2. Strontium has been oxidized to strontium plus 2. The strontium must lose the outer shell electrons because now you have 2 lesser electrons. You lose the outer shell electrons. Going down group 2, you should be easier to lose the outer shell electrons because there is more filled electronic shells. The valence electron, the outermost shell electrons are more shielded due to the inner field shells, right? They contain electrons. So this should be easier down group 2. This should be easier to achieve. That means strontium will burn in oxygen. Strontium will burn in oxygen. It said does not burn in oxygen, so that is incorrect. Without checking number 3, I wasn't sure about number 2, but I'm sure number 1 is wrong. So that means my only correct answer would be 2 and 3, which is C. When you check number 3, you should know about the other trend, which I expected to state at AS level. That is the solubility of the group 2 hydroxide. So the hydroxide is OH minus. You will need 2 of them because the LCM of 2 and 1 is 2. So you need to have 2 of the minus 1 to balance out the plus 2 charge. Going down the group 2, your hydroxide become more soluble. As you will know, magnesium hydroxide, which you get when you try to dissolve magnesium oxide in water. And magnesium oxide is part of your period 3 case study, yeah? So this is pH 9 because it's not very soluble in water, so it's just a weak base. But things like barium hydroxide is very soluble in water and you get like pH 14 strong base. By knowing these few examples, I can get the trend on top of my mind very easily because these are part of my chemistry vocabulary just by knowing a couple of examples. Okay, so number 3 is definitely correct. And of course, we didn't really have to check for that. Once we checked for 2, once we check for 1, we can get the answer straight away. Moving on to the next question, it's saying that which of the following magnesium compound lose mass, okay, lose mass, so gets lighter. They can change the terminology a little bit, yeah? When you heat by a Bunsen flame, so we're talking about thermal decomposition. You are not adding anything to it, you are just heating it. So you're trying to do thermal decomposition. And if you think about magnesium nitrate, so all of this will be Mg2 plus. Top one you have CO3 2 minus. Second one you have NO3 minus. Bottom one you have O2 minus. So you have MgNO3 twice. Then you will get group 2 oxide, which is Mg2 plus O2 minus. You will get 2NO2 and you will get half O2. This is the classic group 2 nitrate decomposition, giving you a brown gas and a colorless gas, which you can't see. And therefore, when you see this in a practical paper, if you get a brown gas, test for this gas as well, yeah? If you thermally decompose a solid, where this solid is supposed to be white anyway. These kind of equations need to be balanced very well because they can ask calculations questions on it, alright? So as you have seen in the other topical MCQ questions in the section A for group 2 chemistry, you will have seen quite a few questions being asked on calculations that involve this particular balance equation. So number 2 is correct. So that will definitely lose mass because you lose them as gases. All right. Option 1. So magnesium carbonate will decompose, okay, fairly easily to give you magnesium oxide plus CO2. Because you give off the CO2 gas, you will lose mass again. But magnesium oxide does not decompose, because how will magnesium oxide further decompose? If you hit this, you get this, and then if you continue hitting this, you also hit this, but no further change occur. Okay, so it doesn't decompose further because what will it form? You want to form magnesium and oxygen? Well, you will have to get the magnesium gain the electron, because this is magnesium 2 plus. You have to gain electrons. It doesn't work just like that, just by hitting. Okay, so you don't lose further mass by hitting magnesium oxide. It doesn't decompose any further. The option must be B, which is 1 and 2 only. In this next question, it's saying that you spread lime, which is alkaline. Okay, so that is your calcium hydroxide. It's a giant ionic solid, giant ionic structure. It's got calcium 2 plus and OH minus, two of them. When you treat it with an ammonium nitrate fertilizer, so this one is NH4 plus NO3 minus. So your formula for the fertilizer is just NH4NO3. What will occur in the treated soil? What will occur in the treated soil? The thing is you need to realize that NH4NO3 can give you NH3 plus HNO3. Okay, so that can happen, all right, because this plus this give you this, but this one can also decompose to give you NH3 and HNO3. That is basic, that is acidic, this is strong acid, this is weak base. When you have a strong acid and a weak base, you're going to be slightly, this is going to overcome this, so your soil is going to be slightly acidic when this reaction happens, because this is a stronger acid than this is a weak base, yeah? So you're going to have the acid from the ammonium nitrate decomposing into HNO3. That can be neutralized by the lime. That's the whole point of adding lime, to give you the salt and water, okay? So there's the salt that you will get dependent on whatever anion is here. If you use Cl minus, this will be calcium chloride. If you use sulfuric acid, you get calcium sulfate, etc., etc. So this is just neutralization. Acid plus base, which is OH minus, and there's salt and water. This first one is about the loss of nitrogen. So this is what you do in a paper 3 practical. You test for NH4 plus by adding a hydroxide, which in this case is OH minus, and then you get salt, NH3, and water. Okay, that is how we produce NH3 in the laboratory. The next part is about calcium hydroxide reacting with CO2 to give you calcium carbonate and H2O. Okay, so which reaction will occur in the treated soil? So I talked earlier about this NH4NO3 giving you the NH3 and the HNO3, and suddenly you get this CO2 where you don't know where it comes from. That can be from the air. Obviously, when you have plants, that's when you need the fertilizer. They can photosynthesize. They can kick out the CO2 to the atmosphere. And remember, CO2 is also an acidic oxide. So what you get is you get a base, and you get an acidic oxide, a weakly acidic oxide. You're going to get the salt and the water. Okay, so there's just the calcium carbonate and the H2O, and indeed all three of these reactions will occur as a result of spreading the calcium hydroxide onto the soil that contains the ammonium nitrate. This one being the tricky one because the CO2 is actually coming from the air and that can react with the alkaline calcium hydroxide. Okay. Moving on to the next question. Which reactions involving calcium and its compound would produce two gaseous product? If I check number 2, solid anhydrous, so no water of crystallization. Okay, so you know that when you have water crystallization, you can give off water vapor, right? So anhydrous there, calcium carbonate will decompose without any water crystallization. It will just give you calcium oxide plus water, not water, CO2. So it's that symbol, solid and gas. Just one gas produced. Because it's anhydrous, there is no water of crystallization. So you want two gaseous product. This one only produce one gaseous product. There can only be one answer, which is number 1, based on the logic of the options available. Okay, in this section B kind of question. So what happened is, if I go through the rest, if I go through number 3, for example, which we know is now wrong from the logic, okay, if we have calcium plus water, obviously in the exam, you get a logic, you move on, but sometimes you might want to check the other option just to make sure that you're not contradicting yourself as well, yeah, if you have some time. So it's going to give you the metal hydroxide plus hydrogen gas. We're going to have to balance the equation no matter what. This is 4 hydrogen because now you have 2 hydrogen and 2 hydrogen and 2 oxygen. That is still just going to be one type of gas. So that is sparingly soluble. Remember, calcium hydroxide is not entirely that soluble, but it's alright in a small amount there, okay? And which, of course, we know the answer is just number 1 is correct, which is D. And as we know about the calcium nitrate, so I've shown earlier in the previous question the decomposition of group 2 carbonate here, magnesium carbonate. So I could just, well, in fact, I don't need to write down. If this is calcium instead of magnesium, it's going to give you calcium nitrate, calcium oxide, NO2 and O2. There are 2 gases being given off when you decompose group 2 nitrate. Okay, so nope. Is it a question? Yeah, this is the question. So there are 2 gases being given off when you decompose a group 2 nitrate. They are the NO2 and the O2. Okay, so I'm not writing an equation, so I don't need to balance it. When you write the equation like I did, obviously you need to balance it, yeah? This is the last question of this 5-question series. I think the modern question, they don't ask you to specifically use the data booklet. You just have to know to use the data booklet. Okay. If we look at option 2, because they want what property would be expected. All right. So we're talking about the group 2 hydroxide. So radium is a group 2 element. So when you think about the group 2 hydroxide, the solubility of group 2 hydroxide, in relation to what I've said in an earlier question, the solubility of group 2 hydroxide increases and radium is somewhere there. Okay, I mean radium is there. This refers to radium hydroxide. Okay, so therefore radium hydroxide is very, hang on. If you read the question, insoluble. That is incorrect because barium hydroxide is very soluble. Solubility of group 2 hydroxide increases down group 2. Radium hydroxide is very soluble. So that is actually wrong. 2 is wrong. Only 1 is correct by logic. Okay, you see, it's very easy to make mistake, right? I nearly was going to put down 2 as correct, but if you read carefully, it's very insoluble. Okay, if I check number 1, radium carbonate will not decompose. So we know number 1 must be correct, right? By logic, it will not decompose at the temperature of a Bunsen flame. If you have the thermal stability of a group 2 carbonate, you know going down group 2, the thermal stability of group 2 carbonate increase. It become very difficult to decompose. So instead of thermal stability, they could put down temperature of decomposition. So it just so happened that I don't even know number 1 is actually whatever it is, but I can work out number 2 is incorrect. Therefore, number 1 must be correct. And it matches the trend that the group 2 carbonate become more difficult to decompose than group 2. And number 3 must be wrong by logic of number 2 being incorrect. Radium does not react with cold water. That is wrong because we know that when you go down group 2, I can just explain this, I guess. When you go down group 2, your outermost shell electrons, they are held less tightly because you have more shells, you have increased shielding. It's easier for the radium to lose the 2 outer shell electrons, and therefore when you react a group 2 metal with water, what you're doing is you are oxidizing the metal to give you hydrogen. So that is solid, liquid, aqueous, and gas. But what is important is this is M2 plus, which means it's M plus 2 oxidation state. This is M0. You need to lose electrons. You need to be oxidized. And this becomes easier as you go down group 2, as I mentioned, due to the outermost shell electrons, your valence electron, being more shielded. Okay, these are concepts from atomic structure. So this is the end of this 5-question series on group 2 chemistry for this section B kind of topical MCQs. If you enjoy my tutorial videos and my channel, so do subscribe to the channel, spread the words about the channel to friends, class group chats, anyone else you think the channel might be relevant and useful for. So thank you for watching. I'll see you in the next video.